Today I am discussing a case with TOF Physiology. This is the case that you see the ventral septum is not intact, it is subaortic VSD, or you say aorta is riding over intervertebral septum, not touching, and there is VSD. Here, what is difference between TOF and double outlet right ventricle? When the aorta mainly arises from right ventricle, that means more than 50% of aorta arises from right ventricle, then it is double outlet right ventricle. If less than 50% arises from right ventricle, then it is TOF, tetralogy of Fallot. So in this case, you see there is aortic overriding, and overriding is more in favor of left ventricle. It means more aorta is still coming from left ventricle. So this is case of TOF. In this case, what you see, there is one, this is left atrium, left ventricle. One structure you see just behind ascending aorta, that is right pulmonary artery. Right pulmonary artery has got very large size. If you compare with left atrium, it is more than left atrium. So this shows that right pulmonary artery is hugely dilated. You see the post stenotic dilatation is present if the stenosis is at the level of valve. That is the finding in this case. You see the next image. You see this is right pulmonary artery, left atrium, left ventricle, and in some views, what you see, this is pulmonary valve and significant pulmonary stenosis, and pulmonary regurgitation is also seen in this image. So in this image you see pulmonary stenosis, this is right pulmonary artery, this is right pulmonary artery, and now you see pulmonary valve and highly turbulent flow, that is because of significant pulmonary stenosis, and turbulence is seen beyond the pulmonary valve. Again, see the moving image, and flow across ventral septal defect, mainly right to left, occasionally reverse, when left, mainly right to left, and occasionally left to right also. Next image, again you see the lower one is flow because of pulmonary stenosis, and upper one is flow because of pulmonary regurgitation. Significant pulmonary stenosis as velocity has between 4 to 5 meters per second. So stenosis is severe. You see what you see in this image. This is main pulmonary artery, RPA and LPA. So main pulmonary artery is usually enlarged, RPA and LPA are also enlarged, and pulmonary valve is quite thickened, more in favor of dysplastic pulmonary valve. Valve is not well formed, defectively formed. Dysplastic means defectively formed. Next image is same image. Again you see the pulmonary valve is defective and not opening, so suggestive of significant pulmonary stenosis. In this image you see left atrium, left ventricle, aorta, right ventricle, subaortic VSD, and hugely enlarged right pulmonary artery. Any tubular structure that is seen in cross sectional behind the ascending aorta, that is right pulmonary artery. So right pulmonary artery is hugely enlarged in this image. You can really appreciate in this image. Next image, again the same thing, pulmonary valve not opening properly, suggestive of significant pulmonary stenosis. One important thing is here, infundibular part of right ventricular outlet is not stenotic. So stenosis mainly lies at the level of valve. This is fourth chamber view. In this image, you see RN RV has more diameter compared to left side. I mean RN RV dilated. This is the flow across pulmonary valve. Significant stenosis. You can see the velocity. In this image also, what you see, a structure that is in cross section. You see right atrium, left atrium, and this is hugely dilated right pulmonary artery. A structure that is just behind superior vena cava in cross section. Superior vena cava seen is long section, longitudinal form, and right pulmonary artery is seen in transverse section because both are in opposite directions, perpendicular direction you say. So whenever you see the longitudinal form of SVC, then you see the transverse form of right pulmonary artery that is just going behind the SVC. So this is hugely dilated right pulmonary artery. In this image you see. The PFO is also seen here. Now zooming the image, you can see the PFO. Occasionally PFO is seen in this image. PFO is seen. In this image you see right ventricle is more in size compared to left ventricle. At the same time left ventricular chamber is D-shaped, suggestive of increased right ventricular systolic pressure. D-shaped left ventricle means right ventricle systolic pressure is much more than left ventricle pressure. Significant PRZ is also seen, so it's suggestive of dysplastic pulmonary valve. So this is the case of TOF without significant infundibular pulmonary stenosis. When there is no pulmonary stenosis, the level of infundibulum, right ventricular outlet, infundibular portion is quite normal in this case. That is usually not the part of TOF. TOF usually has infundibular pulmonary stenosis also at the besides pulmonary valve stenosis. That is quite strange. In that case, we can also say mild alignment VSD with pulmonary stenosis. So by nomenclature, one can say this is mild alignment VSD with pulmonary valve stenosis, but physiologically, this is the case of TOF. Yeah, you say TOF physiology. Means whatever happens in TOF, same physiology is present in this case. At the level of VSD, flow is bidirectional, mainly right to left, because flow is more blue color, longer duration has blue color, it means longer duration flow is from right to left. Shorter duration flow is red color, it means For short duration, flow is left to right. What you say, significant pulmonary stenosis is seen, pulmonary agitation also seen. Pulmonary agitation, this must signifies suggests us pulmonary valve is dysplastic, not well formed, defectively formed. So overall, this case has TOF physiology. We can say TOF, or second diagnosis. We can also say malaligned VST with severe pulmonary stenosis. Again, same image. Whenever you see pulmonary artery significantly dilated, then you suspect significant pulmonary stenosis, because post-stenotic dilation is quite common when the very significant pulmonary stenosis is present. Just revising all the image, RP is quite enlarged, that is just abnormal if you compare with the normal structure. When you see in this kind of image format, 4-chamber view, dysplastic pulmonary valve not opening properly, case is quite interesting, significant pulmonary stenosis. AV concordance is in left atrium attached to left atrium attached to left ventricle and right atrium attached to right ventricle.